Suppose that I wanted to solve e sevenths plus 3 1/3 sevenths. Well, first of all, I'm going to need to get a number line with everything in sevenths. You may wonder, what is the approximate value of e? Well, e is approximately 2.71828. I would also like to note that 3 1/3 is approximately 3.33333. How do I know this? Well, 1 divided by 3, which would be a third, but anyway, if I were to solve 1 divided by 3 using long division, I would get 0.333333333 going on forever and ever. Anyway, to solve e sevenths plus 3 1/3 sevenths, I'm going to need to place my marker at e sevenths. 1 seventh, 2 sevenths, e sevenths. Now because of the plus sign, because we're adding, and because this fraction is positive, I'm going to move the next steps forward or towards positive infinity. And how many steps do we now take? 3 1/3 sevenths. 1 seventh, 2 sevenths, 3 sevenths, 3 1/3 sevenths. If we forget about everything being in sevenths for just a little bit, or landed at approximately 6.051615. Also to note is that e plus 3 1/3 is approximately 6.051615. However, everything is over 7. Therefore, e sevenths plus 3 1/3 sevenths is equal to e plus 3 1/3 over 7. I would like to note that this expression of e plus 3 1/3 cannot be simplified any further and still be exact. For this reason, it looks pretty obvious that I'm adding the numerators. But why can't I add the numerators and keep the denominators the same? Why is that the rule when I'm adding these two fractions? Well, suppose I was just adding the numerators. Suppose I was just solving e plus 3 1/3. I would have my marking at e. So 1, 2, e. Then because of the plus sign and because of the positive 3 1/3, I would move my piece forward that many pieces. And I'm moving it forward towards positive infinity by 3 1/3 pieces. 1, 2, 3, 3 1/3. And I'm left at approximately 6.051615. So as you can see, when I'm solving this problem without everything being in the sevenths, it is very similar to the problem of e sevenths plus 3 1/3 sevenths. The only difference is that in that problem, everything was in sevenths. Therefore, to solve this problem, we add the numerators, but keep the denominators the same. What is negative pi over square root of 41 plus 4 over square root of 41? Well, what is square root of 41? It is a positive number that if you multiply it to itself, you will get 41. And the square root of 41 is approximately 6.40312. So I need to have a number line in which all the major markings have a denominator square root of 41. I would like to note that this little piece here is not 1 over square root of 41. It is more like the leftover to make this whole section equal to 1. You also may wonder what negative pi is approximately equal to. Well, positive pi is approximately positive 3.14159. If you take the negative of both sides, negative pi is approximately negative 3.14159. So I need to place my marker at negative pi over square root of 41, or approximately negative 3.14159 over square root of 41. Negative 1 over square root of 41, negative 2 over square root of 41, negative 3 over square root of 41, and negative pi over square root of 41. Then because of the plus sign, because I'm using addition, and because this fraction is positive, I'm going to have the next steps be going forward, be going towards positive infinity. And the next steps will be 4 over square root of 41, 1 over square root of 41, 2 over square root of 41, 3 over square root of 41, 4 over square root of 41. I would like to note that if we forget about everything being over square root of 41 just for a little bit, we are at approximately 0.858407. I would also like to note that negative pi plus 4 is approximately 0.858407. However, everything is over square root of 41. Therefore, negative pi over square root of 41 plus 4 over square root of 41 is equal to negative pi plus 4 over square root of 41. This expression of negative pi plus 4 cannot be simplified any further and still be exact. Well, it could be 4 minus pi, but what I'm saying is that I cannot write it so without a plus sign or without a minus sign and still be exact. Anyway, for this reason, it looks pretty obvious that I'm adding the numerators. But why can't I add the numerators and keep the denominators the same when I'm solving this problem? Suppose that I was solving negative pi plus 4. Well, I would like to note quickly that this ruler represents the negative side of the number line and this ruler represents the positive side of the number line. So I would place my marker at negative pi, negative 1, negative 2, negative 3, and negative pi. Then because of the plus sign, because we're adding, and because 4 is positive, I'm going to move forward. I'm going to move towards positive infinity. Therefore, I'm going to move 4 steps forward. 1 step, 2 steps, 3 steps, 4 steps. And we are at approximately 0.858407. So that is how we would solve negative pi plus 4. As you may have noticed, it was very similar to solving negative pi over square root of 41 plus 4 over square root of 41. Only difference was that in this example, everything was over square root of 41. Therefore, to solve negative pi over square root of 41 plus 4 over square root of 41, you simply add the numerators but keep the denominators the same. What is 3/5 plus 0/5? So first of all, I'm going to need to get a number line with everything in fifths. Then I'm going to need to place my marker at 3/5. 1/5, 2/5, 3/5. Then I'm going to need to move my marker 0/5. I'm moving it 0/5, so I'm moving it no fifths. I'm not moving it at all. Therefore, I stay where I started at. And therefore, 3/5 plus 0/5 is equal to 3/5. For this example also, we added the numerators but kept the denominators the same. Why did we add these two fractions this way? Well, suppose I were to solve 3 plus 0. So basically the same problem, except everything isn't in fifths. So first I would get my marker at 3. 1, 2, 3. Then I would move it 0 spots. If I'm moving it 0 spots, I'm not moving it at all, and so it stays at 3, and therefore 3 plus 0 is equal to 3. You may notice that how I solved 3 plus 0 was very similar how we solved 3/5 plus 0/5. The only difference was is that in 3/5 plus 0/5, everything was in fifths. Therefore, to solve 3/5 plus 0/5, you add the numerators but keep the denominators the same. The next and final video in this set of videos has 3 parts. It has part 11, which is the summary of the rules about adding and subtracting fractions. It has part 12, which is about counterexamples. And it has part 13, which is a thank you. Feel free to click on this link if you would wish.